Hello, everyone, and welcome to one in a series of informational videos delivered through BC Housing's Mobilizing Building Adaptation and Resilience program. The topic of this session is enhancing climate resilience in new construction projects. My name is Craig Dedels, and I am a sustainability planner at Integral Group. Integral is a deep green engineering firm, and we provide design and consulting services to building projects around the world. Our sustainability and policy team also works in provinces, municipalities, and with others to try and shift the market and move the dial on creating requirements, standards, and guidelines for the design and construction of a more resilient building sector. Our values are very closely aligned with MBAR, and I've had the pleasure of working with BC Housing on this program for the past 2 years. So what is MBAR? In short, it's a long-term, multi-stakeholder program dedicated to increasing our understanding of how we can actually create and design resilient buildings, and then share that knowledge across the building industry in BC and further afield. A major aspect of MBAR is our pilot projects. These pilots offer the opportunity to take emerging best practices in climate resilience and put them to test in the real world. Working with leading developers and designers, we bring the right experts together to carefully assess new and existing buildings and identify strategies to enhance the resilience of that building. For example, at QuadReal's archetype development at Main and First in Vancouver, the MBAR program helped to introduce a refuge room with backup power, cooling, and enhanced filtration, and that can serve as a safe space for residents during extreme events. So now I want to jump into today's topic. We're going to start with some light background and context. We're then going to spend the majority of our time exploring the process of assessing risk and vulnerability for new construction, including the applications of a resilience checklist tool that BC Housing has developed for these buildings. We're going to illustrate this with a few examples of design consideration by climate hazard, though I want to stress that this is just a starting point and nothing comprehensive. We're then going to look briefly at how these design measures intersect with occupant resilience and wellness. Finally, we'll cover some design strategies that we've come to understand through the MBAR program as essential for a building to be resilient. So before we dig in, let's make sure that we're all speaking the same language around climate change. Addressing climate change requires a two-pronged approach. You've got mitigation, and that's actions to reduce the emission of greenhouse gases into the atmosphere. And then you've got adaptation, that's actions to reduce the negative impacts of climate change and to take advantage of the opportunities that come along with it. And so with all that in mind, we can consider climate resilience or building resilience as the ability to anticipate, prepare for, and respond to the hazardous events, trends, or disturbances that come along with climate change. So why should we care about climate resilience? Well, in short, because despite our best efforts to limit greenhouse gas emissions into the atmosphere, we are essentially locked into a certain degree of climate change. Historical observations show that greenhouse gas emissions have caused and will continue to drive warmer temperatures, increased heavy rainfall, and lead to a higher frequency and severity of extreme weather events. Leading climate science right now shows that these trends will only intensify moving forward, regardless of the emissions reductions that we achieve. In short, climate change is happening, and we're already seeing the impacts. Things are only get more challenging from here on out. These changes are going to have profound consequences on our natural ecosystems and the built environment, along with the economic and social systems that are linked to them. We need to be proactive and to plan for future shocks and stresses. Now, you can consider resilience at a variety of scales, including campuses and communities, but today we're focusing on the building scale. Enhancing building resilience means adjusting the way that we design and retrofit buildings using new design parameters that account for medium and longer term conditions. This applies not only to warmer temperatures, but to increased wind and rain loads, and to increasing wildfire smoke and airborne disease vectors. This can take a lot of work, from improved envelopes and enhanced ventilation to flexible cooling systems. Now, fortunately, this work can be win-win for all parties involved. Resilient buildings are better buildings overall. They are safer, more efficient to run, and more comfortable for occupants. What I want to emphasize here is that resilient design strategies have a multitude of co-benefits. So, when should projects teams start thinking about resilience? Well, earlier is always better. It's much easier to incorporate resilient design strategies before budget decisions are made. Some of the largest building decisions, such as siting and orientation, can also have major implications for resilience, and these are things that are very hard to change down the line. That said, late interventions are better than none at all. Through some of our MBAR pilots, we've had a lot of success at introducing resilience measures, even at very advanced stages of design. So, in addition to making safer, more comfortable buildings, considering resilience early on can align with other project goals, including the requirements of the local jurisdiction and other levels of government, funding requirements such as the Infrastructure Canada Climate Lens, organizational climate goals, and LEED certification and other green building standards. So now let's talk about the resilience assessment process. What we've been doing through the MBAR program is conducting a preliminary climate resilience assessment for pilot projects by considering the background information on the subject site, the physical setting, and the planning context, future climate projections using statistically downscaled data from highly reputable sources like the Pacific Climate Impact Consortium, or PCIC, project planning details, and these can vary depending on the stage of design that we're in. So next, we use a preliminary hazard screening exercise to identify the climate-related hazards of greatest concern to the project, drawing from local, regional, and provincial resources and those future climate projections, and then considering how those will interact with the building's intended use. From there, you work with the design team to identify strategies to enhance resilience and to maximize any strategies that are already included and really play up how resilient they can be. This general approach has been captured in the tool that MBAR has developed for easy application across a range of projects. This slide here shows an example of what some of the outcomes of this process might look like. This hypothetical project might be in a developed area already subject to the urban heat island effect, placing occupants at a higher risk during a heat wave from warmer temperatures and into the future. At the same time, it looks like it's not particularly exposed to sea level rise or to riverine flooding. These kind of outputs can then be used to inform building design. Knowing what hazards are most applicable can then help design teams to focus their energy and resources where they'll be most useful. So in looking at climate risk and resilience, it's important to use reputable sources. We're lucky in Canada and BC to have great information available from different levels of government and from leading organizations such as PCIC and the Fraser Basin Council. The MBAR Resilience Assessment Checklist for new construction provides general resources that can serve as a starting point for any project in BC. But then beyond these, it's always important to look for site-specific information wherever available. There might be, master planning documents for that site or a community-specific climate risk assessment plan. So let's try another example. Say that we were evaluating the development of a new mixed-use building in Nanaimo. To assess the project's exposure to flooding, both from sea level rise and from rivers that might break their banks during extreme events, we could ask a few questions. Is the project located in a coastal area at risk of sea level rise, storm surge, or king tides? Is the project at risk from seasonal flooding, which is anticipated to increase with more periods of extreme precipitation? We would then find these answers in provincial guidance documents, like the Sea Level Rise Adaptation Primer prepared by the province, or floodplain maps, and potentially plans from local government. If we determined that the project was at moderate or high risk, some resilient design strategies for the project might be to make sure that the design team is using flooding construction levels that are based on future flooding, not the past, and to minimize the vulnerability of below grade levels that could flood by moving essential infrastructure to upper floors and limiting use to parking. For this same project, we could evaluate the risk of overheating for residents by looking at future climate projections, project siting, and key building design features. From here, a next step is to model cooling needs for 2050 and beyond. MBAR has already developed guidance on this topic, and a video summary will also be made available. Based on these outcomes, it might be appropriate to provide full or partial active cooling, preferably from a low carbon system like a heat pump. If mechanical cooling isn't in the budget at the time of design, then the team can allow space for future equipment and include rough-ins to allow for easy upgrades down the line. One very high-value strategy that has emerged through the MBAR program is the inclusion of a refuge area, which can help to build overall resilience to extreme heat events, to periods of poor air quality, and more. This is a shared space within the building that is accessible to all residents and perhaps to more community members more broadly. It provides a safe, reliable space with essential services that people in the building can turn to in the event that their own units become uncomfortable or unsafe. These spaces can be included alongside or in place of some of the strategies that we've discussed already and can really help to enhance the ability to shelter in place during extreme events. Now, we've talked a lot about assessing risk at the building scale and implementing design strategies to mitigate that risk. At the same time, it's vitally important that building occupants are informed, empowered, and prepared to respond during extreme events. This social resilience can be built through design decisions like shared spaces and by fostering a strong sense of community, whether that's through, building movie nights or through emergency training. And coupling this with the resilient design strategies that we've discussed already can have a huge range of co-benefits for new construction projects and the people that use them. Bringing this all together, I want to highlight a few key strategies that we've come to understand as essential for resilient buildings. These include assessing relevant climate hazards for the site, modeling using future climate projections instead of past, including measures to ensure people can stay cool and breathe clean air, including measures to minimize flooding risk, and ensuring continuity of essential services, including power. These should be considered as a baseline and a jumping off point. From there, it's up to project owners and design teams to find more specific strategies that fit their unique needs. That wraps up the content for this presentation. I want to say thank you all to attending and to all of you who have helped to make the MBAR project possible. Please be sure to keep an eye on the MBAR website for all the latest resilience updates.